Okay, Pythagorean theorem refresher. So the Pythagorean theorem says that a squared plus b squared is equal to c squared. And really all that means is that if you have a right triangle, that the square coming off of this side plus the square coming off of this side would be equal to the square coming off of this side. Mathematically, what that looks like is right here, I'm looking for this missing side. I know that if I take 3 squared and I add it to 7 squared, that those together will equal my missing side squared. So 3 squared, just 3 times 3, that's 9, plus 7 squared is 49, is equal to c squared. Add these together and you are going to get 58 is equal to c squared. Anytime you have a square number here, to undo that squaring, what you're going to do is you're going to take the square root. So I'm going to just take the square root. Sorry, I deleted that by accident. And so in this case, I've got c is equal to the square root of 58. Now, it's probably not super helpful for you all to just say the square root of 58 unless you've got a good way to talk about the length of that, and we will actually do that in the next couple of days. But you could certainly bust out a calculator and get an estimate. In this case, I plugged the square root of 58 into Desmos, and it tells me it is about 7.6. Super useful for you to give yourself a quick hip check, does that even make sense? What should be the longest side here? Definitely the hypotenuse, 7.6. Okay, cool, that seems reasonable. Okay, cool, so that's one example. How is this one different though? I want you to notice in this case, we had the missing side was the longest side. In this case, the missing side is not the longest side. So instead of setting it up just like this, I'm gonna leave one of these as my missing and then fill this one in. So what that will look like is I will say a squared, which is gonna be that thing, plus 11 squared is equal to 17 squared. So a squared, don't know what that is, just gonna leave that like that is. 11 squared is 11 times 11 is 121. 17 squared is 289. Again, that's just like 17 times 17. Then we would subtract from both sides because we got something plus 121 gets me 289. So I'm going to subtract 121 from both sides. And I would get a squared is equal to 168. Just like we did over here, you're going to take the square root. Sometimes you end up with really nice numbers, sometimes not. Now, I do happen to know that the square root of 169 is equal to 13. So I know this is going to be about 13. It's going to be a little bit less, so like 12.9. Let's double check ourselves in a calculator quick. Yep, it is 12.96, but I'm cool with 12 and 9/10. So there is my answer there. So that is just kind of a quick refresher on the Pythagorean theorem. One last thing I will say is that any triangle that is a right triangle will have it be true that a squared plus b squared is equal to c squared. So I'm going to ask, is this a right triangle if I've got a side that's 3, 4, and 5? Or is this a right triangle where I've got a side that's 2, 3, and 4? Well, in 3, 4, and 5, we would say 3 squared plus 4 squared, is that equal to 5 squared? Get 9 plus 16 equal question mark to 25. 25 is the same as 25, so boom, this is a right triangle. No question about it, period, it is. Over here, if we try it, we say is 2 squared plus 3 squared equal to 4 squared. Here I got 4 plus 9 equal to 16, and again, we got question marks here. Well, 4 and 9 gets me 13. 13 is not the same as 16, so this is not a right triangle. Okay.